Good afternoon. This session is on sensitivity analysis, and I will be considering the Blue Ridge problem. And this is a problem that we've solved in class. We've solved it graphically, and we've also solved it using Excel solver. So if you need more information or you forgot how we work this out, you can always refer to the YouTube videos I've uploaded. I've uploaded a video which details how we can solve the problem graphically and also how you can use Excel solver to solve this problem. But as a quick reminder of what the problem states, it's a production problem where we're trying to produce two items. We're looking to produce two items. We have two decision variables. First decision variable is x1, how much to produce from product 1. x2 is how much to produce from product 2. And each product would yield a certain profit. So the coefficient of x1 in the objective function is 350, and the coefficient of x2 in the objective function is 300. So if we had no constraints, we would just simply produce as much as possible from x1. Now, we had three constraints, right? We had the first constraint related to pumps that stated that we had 200 pumps available, and we have 1,566 labor hours available, and we have 2,880 feet of tubing available. So really, those are our constraints due to a limitation in our resources, which are pumps, labor hours, and tubing, specifically feet of tubing. And each resource, for example, resource 1 needs 1 pump, it needs 9 labor hours, and it needs 12 feet of tubing to produce just one item of x1. And similarly, 1, 6, and 16, those are the resources required from product 2. Now, when we solve the problem graphically, we sketch the feasible region, we identify each constraint, and we resulted with the following being the feasible area. And the optimal solution was the intersection. We identify it visually as the intersection of constraints 1 and 2. So we can solve now two equations, two unknown, and we ended up with the coordinates of the point being 122 and 78. So x1 star is 122, x2 star is 78. And the optimal solution is 66,100, which is simply plugging x1 star and x2 star in the profit function. We also solved this problem using Excel, and we got the same solution. Now, when we plug this problem in Excel solver and we ask solver to execute it, we have the option to generate two types of report: the answer and the sensitivity report. So the focus of this session is how to read the sensitivity report, right? So how can I interpret and make use of the values in this sensitivity report? Now, the answer report will state the following. It will give me the optimal solution, right? It will state 122 and 78 are the optimal solutions, and it will state that x1 and x2 are the binding constraints. So when graphically, I can identify them as being binding since the optimal solution is the intersection of those two constraints. And the left-hand side at optimality of each constraint, of each of those two binding constraints, is equal to the right-hand side. And if you recall, I would define the left-hand side at optimality of constraint 1 as x1 star plus x2 star, and meaning I plug in the optimal solution and I will end up with 200. Similarly, the left-hand side at optimality of constraint 2 is 9x1 plus 6x2 star, and I will end up with 1566, which is also equal to the right-hand side. And the left-hand side at optimality of constraint 3, if I plug in 12x1 star plus 16x2 star, I will end up with 2712, which is less than 2880. And the answer report will tell you which constraints are binding and which ones are non-binding. And it will also calculate a value which is called the slack. And the slack is really the difference between the right-hand side values and the left-hand side values at optimality. So so it means that the slack for constraint 1 is 0, the slack for constraint 2 is 0, and the slack for constraint 3 is 2880, minus 2712, which is, this implies the slack for constraint 3 is 168. And what this represents physically is that when I produce 122 items of product 1 and 78 items of product 2, I will utilize all my pumps, the slack is 0, I will utilize all my labor hours, but I will have 168 additional feet of tubing. And really, if you think about it, a binding constraint should have slacks of 0. I would expect it to have slacks of 0. And non-binding constraints would have a positive slack.